All right, in this video, we're going to work through the following problem. We want to take the indefinite integral of the cosine of tangent of x times secant squared x dx. All right, so looking at this integral, we can see that this is not just one of the basic integral facts, the basic derivative facts in reverse, right? It's more complicated than that. So for our class, that essentially means that we are going to use substitution, most likely on this. All right, so in the substitution method, we need to pick some part of the expression to be equal to u and make that substitution and hope that we get a simpler integral to compute than this. And here we can see that there are some a pretty obvious good choice for u in this case. Remember, at the top of the list of good choices for u are parts of the expression that appear inside other parts here. So talking about composition of functions, and here we can see that this tangent of x, right, appears to be inside this cosine x. So that right there says, okay, tan x looks like a possibility for a good choice for u. Second on the list of good choices for u that I talked about in the introduction video are parts of the integrand whose derivatives appear as factors of the integral. And you can see the derivative of tan x is secant squared, and that appears as a product of the integrand. So right there, that is telling us, hey, that this is the most likely the best choice for u here is going to be tan x. Okay, and so take the derivative of tan x to calculate du. The derivative of u is 1 times du. The derivative of tan x is secant squared, and times that by dx. And then what we need to do is to use these two equations, right, to transform every single occurrence of x in this integral into some occurrence of u. And you can see that is pretty straightforward right here, right? We can see that if we just take u for tan x, right, because that's what we picked to be u, and then you can see this secant squared dx, it's just perfect. It lines up perfectly with what we have here, so we can just put that right over to du, and that is it. We switched every single occurrence of x over to some occurrence of u, and we definitely got a simpler integral, right? In fact, this is just one of the basic integrals now. We know that the antiderivative of or an antiderivative of cosine of u is sine of u, right? And then the indefinite integral would be sine of u plus some constant c. And then all we've got to do to back substitute is to replace u by tan x. And that is it on this one.